People and families, countries and governments, businesses and economies, we all need power. Keeping the lights on, the kettles boiling and factory output flowing is vital to life on Earth. Now more than ever before, the energy sector must push the boundaries of innovation to curb carbon emissions and global warming, while still keeping the electrons flowing. Welcome to Powering Your World. Whether it's new ways of generating power, new ways of storing it, or new ways of using our existing technologies, the energy sector is more varied and complex than ever before. We're here in Kazakhstan's capital Astana at the Future Energy Expo, where people are discussing where we're headed next. And sometimes the answer is looking right back at you. At least that's what advocates of nuclear power will say. And it's the Kazakhs here in Central Asia who are the world's biggest producers of uranium. Beneath the baked earth of the Kazakh steppe is one of the country's largest uranium mines. 48 kilometers wide, the metal below workers' feet is valuable and controversial. 10 years ago, uranium prices peaked at $136 per pound. Today's prices are more around the $20 mark. But could future energy policy reverse the trend in the next few years?
We pump sulfuric acid into the ground and it dissolves the uranium. We pump out the liquid for production.
Kazakhstan is the world's largest producer of uranium, the key ingredient in nuclear fuel. About 40% of global supply comes from mines like this one, owned by the state-run company Kazatomprom.
If you look at current nuclear generation, it's about 11% of global power production and less than 1% of CO2 emissions. And without nuclear, it's very hard to see how we would be able to achieve the targets that have been set for 2030 and 2050.
Those targets are from the Paris Agreement to address climate change. 152 countries so far have pledged to keep global warming well below 2 degrees. That means weaning ourselves off fossil fuels.
We are getting word of a powerful earthquake that has hit Japan.
But the Fukushima disaster in Japan in 2011 has had serious consequences for the nuclear industry. Safety was called into question, and 6 years after Fukushima, only 5 of Japan's 42 nuclear reactors are operating. And there lies the trickiest issue with nuclear power: trust. Science is on side when it comes to carbon emissions. In fact, they're relatively low in nuclear energy production. But can the public be convinced that greater investment is necessary? Donald Trump is certainly convinced, despite declaring he wants to withdraw from the Paris Agreement.
We will begin to revive and expand our nuclear energy sector, which I'm so happy about.
In 2016, nuclear energy provided more power in the US than all renewables combined. China is also expanding, with 36 nuclear reactors in operation and 21 more under construction, according to the World Nuclear Association. So is China making up the difference where Europe is a bit of a vacuum here?
Yeah. Actually, surprisingly, over the next 4 years, we're going to see 60 new reactors. If you consider that the current market is 450 reactors, that's a very substantial amount, either being commissioned or coming online. And it's places like UAE, China, Jordan. The estimates are anywhere between 30 and 60% increase in nuclear baseload generation from today. So there is a lot of growth.
Mines like this one, 6 hours drive from Shymkent, are the bread and butter of the Kazakh economy.
This is a filtration pool. We bring the uranium solution here to filter it for processing.
What's left is this, uranium oxide, more commonly known as yellow cake. Production here is around 2,000 tonnes per year. When enriched, it's used in nuclear fuel pellets and nuclear weapons. More than 1 billion people still live without electricity, according to the International Energy Agency. And it may be the reason nuclear power and the price of uranium makes a resurgence in the years to come.
Mr. Bosenbayev, thank you very much for joining us. When people think of Kazakhstan, they think of energy. What is the future of energy in Kazakhstan?
If we are talking about demand for oil, for example, we think it'll peak in the 2030s and will start decreasing afterwards. So by 2050, it will return to current level, which is about 95 million barrels per day. And the reason for a lower demand for oil after the 2030s will be the mass sale of electric cars. Therefore, based on these conclusions, we've decided that we must intensify oil extraction within the next few decades. Our task is to fully develop the oil, gas and petrochemical industries, and we are working on it now. We are holding talks with Saudi Arabia, the UAE and their subsidiaries.
So how does a country like Kazakhstan, that's so well known for exporting hydrocarbons, radically re-engineer its energy future in a day like today, especially given as you've adhered to the Paris Climate Change Accord?
We have to do something about it because we have international obligations within the Paris Agreement. So we have a job to do. Just 2-3 years ago, Kazakhstan didn't have any renewable resources. And now we've built 300 megawatts worth of energy and more than 50 small and medium solar and wind stations which are now functioning.
And how does nuclear energy play into that strategy? Kazakhstan is the biggest exporter of uranium yellow cake. This is a vital commodity for your country.
Yes, we control about 40% of the market. Many European countries plan to stop using nuclear plants, but Arabic countries such as the Emirates and Saudi, China, India and Iran, they all have a strategy to build massive power generating units. And we expect that Kazakhstan fuel will be used in these reactors. And we hope that by 2019, the first 5 new Chinese power stations must run on Kazakhstan fuel.
Well, obviously 2017 sees the Expo here in Astana, the capital of Kazakhstan. How important is that for your country and your future in terms of powering it?
You've probably seen that the Expo sparks great interest. So many people come here. Over 100 countries have presented their projects and their vision of the energy of the future. It's interesting because people want to know what the future holds for them. It's an attempt to have a look into the future. It's very important because we are on the verge of major changes that will affect all of us.
Join us after the break as we'll be looking at the next generation of wind power technology. There are some new ideas around and some may say it's child's play.
Welcome back to Astana, the capital of Kazakhstan. Well, it wasn't long ago that renewables were considered to be the new frontier of energy production. Today, studies have shown that in fact clean energy can be just as cost-effective as traditional fuels, in some cases more so.
Ready for liftoff in one of the windiest spots in the UK. These kites are the next great hope for the wind energy industry and have attracted more than $9 billion of investment.
We see our first commercial deployments in the early 2020s, and that's when we sort of see us actually making significant impact on the energy mix in the UK and other locations.
Kite Power Systems is the UK's first company to fly kites in search of energy, setting up an airfield near Stranraer in Scotland.
This kite sitting behind us is around, I think it's about 17 or 18 metres squared, and that's enough for around 40 kilowatts of electricity. So 40 kilowatts of electricity is enough to power around 60 or 70 homes. But if we scale this up to 500 kilowatts is going to get us close to 600, 700 houses.
It's almost a limitless resource. Kites at the top, obviously, they're like the engine. Underneath those you have a control mechanism which physically steers them, which is the pod. And then there's a tether that then connects that to the ground. And all the power is then generated on the ground by the winch. So
the infrastructure is small and cheap and easily portable. So cheap, in fact, that Kite Power Systems hopes to operate without subsidies once up and running, a boon for any government.
When we look at the future, so our levelised cost of energy will be such that it will be significantly lower than the wholesale price of electricity. And at that point, we should be subsidy free.
Well, I think it's really exciting what's happening with Kite Power in Scotland. I think Scotland is definitely a home of innovation when it comes to renewables. And it's not just in wind, we've seen it in wave and tidal power, and even in solar power, believe it or not, in Scotland. And it's now a place where companies want to come and test their devices.
Companies, including Norway's Statoil, which is building the Hywind project. It's the world's first floating offshore wind farm, cutting out the need for costly deep-sea moorings. Scotland generates over 50% of its electricity from renewable sources, according to the WWF.
So this kite's the baby. The ones that we've just built and are now roughly 5 times the size of that, 70 square metre.
So we have enough funding at the moment to actually build the 500 kilowatt system and demonstrate the 500 kilowatt system and hopefully take that to commercial readiness.
Philanthropist Bill Gates has invested billions in green technology, and he's identified kite systems like this one in Castle Kennedy as a prospective magic solution to the world's energy needs. Kite Power Systems have their eyes on the skies and very much hope he's right.
Scotland really is at the forefront of wind power production, but there's no point in making all of that renewable energy if you can't store it effectively. Well, across the water in Ireland, they're finding a solution to that very problem.
Electric development whose immense turbines throb like the very heart of the new Ireland.
As early as the 1920s, Ireland had an eye for renewable power. This is the Shannon Hydroelectric Station. Still operating today, it kick-started the electrification of Ireland and was one of the most ambitious projects of its time.
We were lucky that we were 100% renewable in those days, and maybe that's where our future lies as well.
Today, the island of Ireland is still leading the way with energy innovations. EirGrid operates the national power system.
It's really about meeting supply and demand on a minute-to-minute basis. We are doing something really groundbreaking here. We are doing something that's very fundamental for not just for Ireland, but for, energy users all over the world.
The technology she's referring to is flywheel hybrid storage. As more and more renewable energy comes onto the grid, operators like EirGrid are searching for ways to meet clean power targets whilst keeping supply stable for consumers. That means storing energy effectively and efficiently for when it's needed.
So this is the flywheel here. It's spinning on a vertical axis. We take power in from the grid to spin it up to 16,000 RPM. It's operating in a vacuum. If the grid needs more power, we can inject it back into the grid very rapidly, and we can go from 0 to full output in half a second.
The plan is to make the most of windy days for when there's a shortfall of clean energy on the grid. Adding flywheel storage improves on batteries alone, which have a shorter life.
This is the first hybrid of flywheels and batteries in Europe.
The big challenge at the moment is that we are looking to have 40% of our energy from renewable energy targets by 2020. It means that we would need to operate the system with levels of wind up to 75% at times. So that represents a really fundamental change.
The hope is that flywheel technology will give that extra flexibility to Ireland. An island nation with few energy interconnectors, everything has to be managed and balanced on these shores. There's little opportunity to import or export with neighbours. In terms of sharing knowledge, Schwunkhad are already taking their know-how to other markets.
There's a massive a massive opportunity in China. They have many wind farms built which they cannot connect to the grid. So they have lots of wind farms just spinning, but they're not able to export the power onto their grid.
The renewable energy landscape is changing fast. Integration of new technologies with existing infrastructure and systems is key. In Ireland, Future Energy have passed the demo stage, with permission to install a commercial 20-megawatt hybrid flywheel battery plant. Another first for Ireland, it'll be the only project of its kind in Europe and could be online as early as 2019.
Flywheel technology is still in its infancy, but there's hopes that it could really change things when it comes to energy storage. When we return, we'll be back here in Kazakhstan looking at one of the vital ingredients for clean technology, rare earths. Welcome back to the Future Energy Expo here in Astana. Well, rare earths are exactly as described, valuable and scarce mineral deposits found in the ground. Here in Kazakhstan, they're mined, processed and then sold on to companies who use them for a variety of applications, from wind turbines to electric vehicles. Stepnogorsk in northern Kazakhstan. The Soviet architecture is a reminder of the past. This city used to be secret, missing from many maps. Once, biological weapons were made here. Today, it's making a reputation for other complex chemical processes.
The raw mineral is delivered by train. It's the leftover byproduct of a former Caspian chemical factory. We process it to make a rare earth concentrate.
Rare earth elements are a group of 17 metals, and here they are in their rawest form, sacks of earth, a valuable and sought-after commodity. The global market is expected to grow to more than $12 billion by 2021, according to market researcher Technavio's 2017 report.
Rare earths are only found in certain specific parts of the world, including here in Kazakhstan. But you're probably more familiar with them than you might think. For instance, they're used in mobile phones like this one, and also in a host of clean technology as well.
Energy isn't just about powering our homes, it's about the way we move. And 1/3 of global energy is spent on transport. Rare earths are vital ingredients in the motors used to make many electric vehicles, including the most exclusive from the world of Formula E.
Using electric motors with magnets, we have the highest power density, and that is why probably most of the teams have raw earth materials in the electric motors here in Formula E.
Reducing petrol and diesel consumption is high on the list of priorities for environmentalists, and countries like Kazakhstan have the materials which could make a difference.
We call rare earth the vitamins of the metallurgical process. Even a tiny amount of this element significantly changes the capabilities of metals and alloys. They are used in computers, supermagnets, for electric vehicles, and in the renewable energy sector.
This processing plant opened in March 2017. The raw earth that it receives is a byproduct of uranium mining in the West. Each shipment is tested for consistency and humidity. By 2018, the goal is to have 1,000 tons rolling off the production line, ready for sale onto the global market.
Up until now, we haven't really had an opportunity to exploit those markets. We see that market growing substantially, and so what has been essentially a waste product until now, we hope to be a future source of revenue.
Currently, less than 1% of the global car fleet is electric, according to the World Energy Council, but growth is strong. In July 2017, the Swedish car manufacturer Volvo announced that every vehicle launched from 2019 onwards will have electric motors, which could signal a turning point for the industry at large and begin to drive down demand for traditional fuels, changing the energy sector's shape and this corner of Kazakhstan's fortunes for the better.
From the ground to the sky above, imagine if you could replicate the power of the sun with the mere touch of a button. Well, scientists in Germany are hoping to do just that.
Sunlight is by far largest artificial sun in the world. It's a research facility, an array of 149 lamps. Together they produce an amount of light which corresponds to 100,000 household bulbs. That's 10,000 times more powerful than natural sunlight. The bulb inside our modules is a commercial cinema bulb. It consists of two massive electrodes of tungsten. The power of our light can be focused to a spot of a diameter of 15 centimeter and relates to a temperature more than 3,000 degrees. We used about 15 lamps, and their concentrated light was able to burn a hole into this massive 20 millimeter thick aluminium plate. With a power of 149 of these lamps, I guess we would be able to evaporate this plate in a few minutes. Our vision, our dream is to generate fuels from sunlight by using temperature only. We want to split water into oxygen and hydrogen. Hydrogen is called like the golden egg of any fuel. It has the highest density of energy of all chemicals. We could use the hydrogen to create synthetic fuels for aeroplanes. I'm extremely proud. It's my baby, and I had the opportunity to build it. We hope it will be the next generation of solar power. We hope to be ready in 10 years for industrial application.
The Sunlight project in Germany, one of a number of new solutions transforming the energy sector today. From Astana in Kazakhstan, this is Powering Your World.